F by x. K equal to how much? F by x. Sir, I can write like K equal to Fx or df by dx. Now you find the value of K. Now you find the value of K. How much will come? I think I am missing negative sign. Minus there. K equal to minus half. F value how much will minus 2ax plus 4bx cube upon x. You can take negative inside. 2a minus 4b into x square. 2a minus 4b into what is the x value we have got? A by 2b. A by 2b means this one. A by 2b. 2 times getting negative. Any mistake we have done? Check now. Check that. Force value 0 3. Wrong. F is equal to minus f by x or df by dx. See here. What is the df by dx? What is the df by dx? df by dx. Here we have done wrong. People are not telling this one. This one. 3 4 12. Here we have made mistake. 6. It should be a 6 not 2. Now you tell me a equal to minus of 2ax plus 4bx cube upon what it is x minus of minus plus 2a minus 4b into x square. 2a into 4b into x square means what I write? A by 6. 2 times 3 times 3 to the 6 minus b cancel. So 3 to the 6 minus 2 4a by 3. K equal to how much we have got here? Correct? Check now. K equal to 4a by 3. Is it correct or not? K. Okay. Now you know but K equal to formula. But K equal to m into omega square implies omega equal root of k by m. Substitute here directly. Omega equal to root of k value how much? 4a by 3 upon m. You get 2 root of k by 3m. Cheeky. How much you have got? 2 root over a by 3m. See the possibility there? Any mistake? Suppose if you take k value minus df by dx, what we write here? Minus df by dx means 2ax minus 12b into x cube. Now take this up here. See here all of you. We have found the value of what? X. And then k is equal to f by x. We use the formula. K equal to m into omega square. Omega equal root over k by m. Then 2 root of k upon 3m. So there. Not on this. Suppose if we use the df by dx, what do you get now? Df by dx. Right. Then why here you have written 12? Why it is 12 here? Anyone? Why we have written 12? Is there 12? F equal u equal to minus ax square plus bx for 4. We have written wrong. Once you see, I check now. Once again, differentiation u is equal to minus ax square plus bx to the power of 4 minus du by dx. Minus du by dx means how much? Minus 2ax plus 4bx cube equal to 0. Implies 2a equal to 4b into x square, x cube, x square. Now x equal to root of a by 2b. This is okay. And df by dx how much? Minus 2a plus 12b into x square should be equal to how much? df by dx equal to 0, then 12b into x square equal to 2a. X equal to root of a by 6b. So we have two conditions for the stable equilibrium. We have two conditions for the stable equilibrium. See now, we have two conditions for the stable equilibrium. df by dx equal to minus 2a plus 12b into x square equal to 0. For this, x is equal to a by 6b and x is equal to a by 2b. For stable equilibrium, f is equal to 0 for minima as well as df by dx also equal to what? Two values. X is equal to a by 2b and x equal to root over a by 6b. So now you confirm that here one small correction there you see, not this, one small correction there. X equal to a by 2b, f value 0. Is the df by dx value should be 0 at a by 2b? Is df by dx value should be 0 at a by 2b? No. df by dx at a by 2b, a by root 2b, df by dx, see here, k equal to minus df by dx, minus, what is this, minus 2a plus 12b into x square, 2a minus 12b x square, at x is equal to root of a by 2b, 2a minus 12b into a by 2b, then what we get? Minus 4a. So k equal to minus 4a. But give me the modulus, no problem. Then what we write here? M into omega square equal to 4a. Omega equal to 4a by m. Omega equal to root of 4a by m equal to root a by m. This is also be there. What condition we need to follow here? See all of you. All you just concentrate on board. You value this. F minima minus du by dx equal to 0. F is maxima. F is maxima implies df by dx equal to 0. Hey, anybody, when the force is maximum? When the force is maximum, when the force is maximum, is at equilibrium position or at extreme position? Equilibrium or extreme position? F value 0 here and F value maxima here. So at extreme position, so what is the amplitude here? X should be equal to A. At extreme position, df by dx is equal to 0. X value equal to how much? A by root of. See there. All you just see there. So A value should be a what? Maximum. Amplitude of the oscillation will be root over A by 6b. So the oscillation should be occurs between the 0 and the maxima. So at what position we need to get that df by dx is equal to what? Formula minus 2a plus 12b into x square. If you take x is equal to what is that? A by 6b, we get df by dx is 0. So x value between the what? 0 to what? Root a by 6b. That's why we have taken a by 2b. Take it answer. Answer will be a what? Option B or C? This one you can take 2 root over a by m. This one. 2 root over a by m. See the concept here. Chances there to make mistake. X equal to a by 2b, number 1. F is maximum at extreme point. Then df by dx is equal to 0. Implies x is equal to 0. Therefore, amplitude of oscillation A equal to root over a by 6b. At this position, particle is at extreme, should not move further. But at this position, it moves towards the extreme or towards the peak. Can take this. x is equal to a by 2b. By putting k equal to what? df by dx. Keep in the modulus. We are trying to apply the force from the mean position, that is F should be varies with respect to the x. Now down multiples about the equilibrium concept. We have secured amplitude of oscillations number 1 and also position of the particle is in the equilibrium root over a by 2b and frequency of oscillation will be 2 root a by m, 3 points. From this question, we have got 3 points, 1, 2, 3. Not down 3. Keep in the bracket all 3. First we find x value, represent the mean position and also maximum amplitude, represent the extreme position and then frequency of oscillations at x equal to 2a by 2 by means df by dx at x equal to root of a by 2b. Now down under this. That's why I'm told don't see the options. Question from the more than one option. 1, 2. Sir, I can put x is equal to a by 6b. If you put x equal to a by 6b, what we get df by dx? Easy. If we put a by 6b, what we get df by dx? Should be 0. Should be 0. Note down under this. I have written good. Now you see another model. Another model, simple and important. Number 2. Block of mass M. Of oscillation of block will be time period of oscillation of block option A pi into root of m by k. Option D, 2 pi root of m by k. Option C, 2 pi root of 2m by k. Option D, 2 pi root of 2m by pk. See the another multi-conceptual pulley cum springer. Pulley cum springer. So this one we go shortcut mode directly. All you listen once. All of you listen once. I explain. You just listen to the word. Then we know the system here already. For example, if it is a springer, it's not a springer, it's a stringer. Is the block should move down like this is there? Is it move down? No, no. But you come here. You come here. If it is slightly displaced down, x. Now is it oscillates? Is it oscillates? Is it pushed down and released? Is it oscillates? Yes, because of the what? Springer. Now you can go directly. You go directly. I give you the numbers. You see, 1, 2. This is the pulley. Formula we know. We know that. We know that. AP equal to what is this one? A1 plus A2 by 2. AP equal to A1 plus A2 by 2. We proved already. AB. Of course, I can write x be equal to this one we don't know. Let it be x dash. X dash plus this one how much? This one. Is there any elongation in the path 2? No. So 0 by 2. So suppose is moving by x equal to x dash by 2. So x dash equal to how much? Why is this one required? Listen all of you. For example, here tension T. This one also here what? T. But here how much? 2T. This is how much here? 2T. This is how much? 2T. And now we can use the principles step by step. This tension should develop the restoring force in the what? Springer. T is equal to formula. T equal to how much? So T, the restoring force developed in spring is equal to phi equal to T equal to minus K into X dash. Minus K into X dash implies T equal to minus K into what I write here? 2x. Now you see what is the restoring force on the block? What is the restoring force on the block? Block moving downward with x. What is the restoring force on the block? Mg equilibrium no initially. When you tend to pull down, then is moving up. Due to what? Due to what? 2T. So now what I write? Restoring force on block is Fr dash is equal to, of course I can use F block equal to what I write? 2T equal to how much then? How much? Minus 4K into X. So you can write MA equal to what is this? Minus 4K into X. K equal to 4K by M into X. 4K by M into X. So A is equal to minus 4K by M into X. A is equal to minus omega square X. Omega value 4K by M means to top K by M. What is the time period of oscillation? T equal to 2 pi by omega. So pi root of m by t. See the procedure. Initially comes in the equilibrium because of the spring, and then we can push it down and release by a displacement x. So when you come down, the restoring force more 2t greater than the t, then only it should be executed in to and fro motion. Not on the basic procedure. Number 2, see the model. Standard model, it's also be a JEE question previous. It's also be a JEE question. JEE and single answer type questions, of course for multiples. Both cases it will be useful. What they ask to find here, you see the question, just you see that. You did in 11th, I think, maybe. May or may not you remember this now. Just you try to memorize once again. See the question here. Chances there to oscillate or not? Just you think practically. Suppose if you just push to the left and release, what happened? Is oscillates to and promotion. Here you come, push it down or it move up, then release. Is oscillates to and promotion. Possible? Possible or not? Yes. Take now. Question you note down. This is a linked concept with what? Rotation with acceleration. People need to get an idea how to solve the questions. Seen and all, I explain because we need time to know more models. I explain, you just see the model. Maybe you get a thought about this like this. See here. All you just seen and I give you how to approach into this. For example, you come. If you push it like this, left side, and then release, then what happened? To and fro motion. When you push means leftward, what is the direction of the restoring force on this spring one? What is the direction of the restoring force on spring one? Suppose is x, right or left? Right side. So at the same time, this side is what moving like this, displacement. What is the direction of force? Here spring number 2. What is the direction of force? Left. And now you see this F1 here, this is F. Both are displaced by same distance, x. Equal and opposite. Resultant force is 0. But these two forces causes torque, means they develop some torque. You know tau is equal to formula. Tau equal to how much? I into alpha. Then problem over. Tau equal to I alpha. So we are going to do this. The principle is angular section. Alpha equal to minus omega square theta. See, I prove now. Listen. Suppose this is the position, you can take P. The rod position is P here initially. Now he is displaced like this. By how much turn this x? This is also how much here? X. Here how much angle made? Theta. Here how much angle made? Theta. So we need to calculate theta. You know this length is L by 2. This is L by 2. This is also L by 2. This is also L by 2. Now what we write? You tell theta equal to. Here all angles are very small. All angles are very small. So that what I use? Then what I write? Theta equal to arc length. X by length is how much? L by 2. We'll get 2x by L. Any doubt on this? Any doubt on this? Now you see, this is the force F. Here force is F. Therefore, the resultant torque on a system due to restoring forces is how much? Restoring forces is what I use? Tau equal to any point you can take, no problem. Tau r equal to tau due to 1 plus tau due to 2 equal to I alpha. Now telling tau due to 1 F minus F into restoring force minus F into what is the perpendicular distance of F about the point P? F perpendicular distance. See, both are moving like this. How much not a perpendicular distance? L by 2. So L by 2 plus upper this also minus F into L by 2 equal to how much? I into alpha. Now minus F equal to formula. One step. Minus F equal to alpha. F equal to how much? But F equal to kx. So therefore minus k into x L is equal to I alpha. Minus k into what is x? X is equal to how much? Theta L by 2. Theta L by 2. So what I write? Theta into L square by 2 equal to what is I? What is I? Moment of inertia again. I of rod about P equal to M into L square by 12 because center. So M L square by 12 into alpha. So what did I L square cancel? 2 6 times. alpha equal to minus 6k by m into theta is in the form of, so what is omega root over 6 by m, tan theta equal to 2 pi by omega 2 pi root of, see that formula, all you see the formula here, t equal to 2 pi by omega equal to root of 2 pi root of m by 6. Then how that is we approach into this question, step by step you see. First we have found theta in terms of the lateral displacement, and then we have found resultant torque, equate the torque is equal to is alpha, and finally we have proved alpha equal to minus omega square theta. It should be an angular section. Now omega equal to pi root of m by 6k. Options are written on here. M by 6k. Options also are written. Suppose if you take m is equal to, sorry, I equal to mn square by 3, you lost the mark. Take care. If you take m I equal to mn square by 3, you lost your mark. Take care, Nana here. You want to do one more similar model? You want to do one more similar model? Try. You try and tell me. So try. Options are same. Options are same. Same options. But only one spring. Example. For example, if they be like this, then what you do? I want you people should know how to approach into them. Last but not least, Anyone try? Try and tell me the answer. Answer and answer. See, just you if you push it down or up like this. So what we can do like this is the procedure. By x angle theta. Compression also be there x here. Compression also be x. So what we do here is that this is L. Theta equal to x by L only. X equal to theta L. Now force direction upward. So torque due to force is equal to tau equal F into perpendicular distance L equal to I alpha. So minus kx into L equal to ml square by 3 alpha. So minus k into x value how much? Theta L. So L square into theta equal to ml square by 3 of alpha. Cancel. Alpha equal to minus 3k by m into theta. So omega equal to root of 3k by m. Time period equal to 2 pi by omega. 2 pi root of m by 3k. See where you have made mistake, just check now. Any difficulty here? Any difficulty here? First one only we can write neatly every step, but second time procedure direct. 1, 2, 3. Torque F upward, perpendicular distance only L. This is the fixed point. Fixed point here. About the edge, ml square by 3. This one have you got? This one. Have you got this? Another paragraph question waiting for you last but not least. It's also be a linked concept with block on block. Note down the question neatly first. two blocks A and B are placed one over the other and connected with a spring of force constant 600 Newton per meter as shown. The block displaced by 50 millimeter from its equilibrium position and release. Then time period of oscillation of the system will be bracket mu is the coefficient of friction between the blocks. Then one thing you confirm from this question, is there any case to block B lose the contact with the block A lose the contact with the block B? Any case here? Time period of oscillation of system means both blocks are moved together, should not slide from the surface. There is no chance to lose the contact. Chance of block A to lose the contact with the B. That you can observe. Because we need to find mu here. Greater, lesser, both given. Is it required more or less? Just you share with me now answer. When it is tends to oscillate, what type of force acting on it towards the center? Towards the center. Block A, on block A, what type of force? Restoring force. Restoring force is equal to formula. Kx. K into x value, how much given? 50 given. So K is equal to formula m into omega square. So m omega square x should be equal to how much? Should be greater than or less than or equal to friction, or greater or less than or equal to friction. So away from center or towards center, one force is acting minus kx, this one at this side. So you can take like this, the friction. M omega square x, for example, F. This is the friction. This F value, small f, is less than or equal to F or greater than or equal to F? Both. Which one? Which one is possible when both are oscillates to and fro? F less than or greater than? Very good. See here. For example, capital F is greater than the small f. Capital F is greater than the small f. Then automatically what happens? Block A lose the contact with the surface, but it does not lose the contact. So F value should be less than the limiting friction. Answer is F is less than or equal to F, or friction is more than the external force. Small f is greater than or equal to f. Then you get the relation easily. They ask you to find the value of f. Then you can. Homework. Only one question. Homework. Try and tell me. More there. I've selected few questions from our material. One. Okay, this part you do. The remaining I give you on tomorrow. After giving the time period and frequency of pendulum. Okay, Nana? Thank you all. Thank you for your patience. Keep practice those things. Help you a lot. Goodbye. Bye-bye. Take care.